if you remember, we start talking about rectangles, and I hope that you have done the exercise, or at least you have the chance actually to go and see the software and start practicing on the software, because the key actually is always to have enough exercises. The more that you do exercises, the better you will become in any software, for that matter, not only any CAD softwares, any software. The required is always to go and practice. And last time, just to summarize what we did, is actually talking about the object snaps in here at the bottom. And how can we have object snaps, whether they are running or they are only current ones, or we can use the shift right key. We talked also about the rectangle, and today we will talk about as well other ready to use commands, which is today I will talk about polygons. Of how can I draw a polygon? These are some polygons that you can draw in AutoCAD. By definition, the length of the edge will be the same, and then the number of the legs that you need. And there are several ways actually of doing this. This is just me until everybody is in. I'll just review the rectangle. As you can see, a rectangle can be drawn in many ways. The one method that I used is actually after I go and click on rectangle, then I have to go and find.
Can I see your shared screen?
I will share in a moment. I'm just waiting for. Okay. So, do you see it now? Do you see it, everybody?
Yes, Doctor.
All right. So we will talk about rectangle just for repetition. Last time we did this. I'm just trying to review the most important things in drawing rectangle. The first thing that we go into specify the first corner. And once we specify the first corner, then we have the rubber band effect in here, as you can see. And what you can do is always right click or look into the sub options in here, whether you are talking about the area, or you can go with the dimension, or you can go with the rotation and specify an angle. I focused on the dimension, and I said we use 2 dimensions to describe a rectangle. The first one is the length, which is actually the horizontal. I'm just reviewing for now. This is just things that we covered already in the past exercise. So the length always horizontal. So we can go, for example, I need something goes as 15. And then we will go into the width, which is always the vertical inside this command. And AutoCAD is telling me that in here, specify width for the rectangle. And then I can go, for example, 10. And this will be my rectangle. Usually it depends on the units. So the units that I am entering now are the default units in AutoCAD, which are inches. How can you make sure what are the dimension the units type? Always, first let's finish the rectangle. I can go into the command menu in here, and I go in units. Once I have the units, it says that I'm using architectural type of inches. I don't want to go into that architecture and other types. I will focus only on the decimal, because this is the widely used one, specifically for civil engineering applications as well as mechanical engineering applications all the way. And last time I drew this couch, if you will, in front of you. We will repeat what we did. I will go with rectangle, then I'll pick an arbitrary point in here, and then go right click and go dimension, and I will enter the dimension for the largest of these rectangles, the vertical one. The back support will be 10 by 58. This is the rectangle, and I can place it in any quarter that I want. I will use this quarter, and then after that I will go into my object snaps, make sure that I have running object snap For example, I always have these three selected. Most of my work, I select the first three in here because these are the most popular ones. And then I will go, and the rest usually I utilize using the shift right click menu, which will bring for me very similar commands to these ones in terms of the object snaps. But for the running object snaps, usually I focus on the first three, unless I know that I'm going to use, for example, intersection all the time. Then I will put it, or I will look into the drawing and see, for example, I have lots of perpendicularity that I will use, or for example, I have tangents and circles I'm going to use. I will make it running. Otherwise, I will keep it only the first three because these are the most widely used ones and the ones that you're going to use all the time in most of the drawings that you will see in your life. To lesser extent, the others. I will go with the rectangle again. My object snap, once I go near the selected running object snap, I'm selecting in here three. One of them is the end, the other one is the mid. Now, if I am closer to the mid, it will snap to the mid. If I am closer to the end, it will snap to the end. So I will go in here, and then I will go and see my couch in here. Right click again, dimension, and X is 24, on Y or the width is 6, and I will place it in here. Similarly, I will continue from this end as well. Right click and dimension, and I have the rectangle is 26 by 23. So I will go 26 enter, 23 enter, and place it wherever I want. I can always go to and draw from this corner as well. Right click. Of course, we'll learn a faster way when once we reach today, inshallah, the modification. We will be doing things in even a much faster because I will not only depend on drawing, but rather I will draw something and then modify it. So dimension again, and that would be width 24, length equal to 6, and this would be my left armrest. And then I will go with another rectangle to finish the seat. I can select this corner up until this corner or enter the dimensions. And this is how we actually draw using rectangles. So that's basically most of the more important stuff that we covered. Of course, we covered other things, but these are the most important things that we covered in our course last time. If you have any question, please communicate with me in the email. Usually I will respond. And if or in Teams, if you have access to Teams, then you can also write in the chat box. My email is available in the course. You can always send me an email. If I don't receive your email, then I will not respond. So you always need to remind me that you send me an email just in case it went into the spam or any other filtration. I couldn't see it, then I will not be able to see your email. Any question, ladies and gentlemen, anything that you want me to repeat, to clarify, any thing that you need me to actually further explain or give examples? You can open your mic, you can speak if you like. All right, so I will focus today on the polygons. Actually, let me wait for 3 more minutes and see if somebody else, because I always say that you're going to start the course at 3:15 to give enough time for people. While we are doing this, I will look into these polygons, and we have different types of polygons. The common thing between all of these are actually can be drawn using the same command. And this command is the one that we will start with. Notice that when we want to start this drawing, let me always go into the ortho mode, the mode settings at the bottom in here, get rid of all of them for now, just to make sure that we will start, all of us will start from scratch. Again, you will be always able to check the units of your drawing. For example, if I want to check the units in here, I can go also to the big letter A as well, go down to the drawing utilities and come back in here and select units. It will tell me that what I'm using in here are decimals and inches, which means that if you want to open a new file, we are using the ACAD. The ACAD template defaulted to inches always, while the ACAD ISO will be defaulted to centimeters, meters, and the SI system of units. So I want you always to know ahead of time of what units you're gonna actually use. Just to make the connection, an inch is equal to 2.54 centimeter, in case you didn't have chance to see these or use them before in high school. Then each 1 inch would be equal to 2.54 centimeter. These are the conversion units basically. 1 foot is equal to 12 inches. Similar when we say 1 meter, for example, equal to 100 centimeter. Each 1 foot equal to 12 inches. And then we have the yard, which is approximately 3 feet. Which is approximately 92 centimeter, something like this, if you hear about yard and so on and so forth. Now I'll start officially. This is 3:15. Sometimes I need to wait for 15 minutes to make sure that most of you are in already. I will talk about these polygons today, and in here we have 3 edges, 4 edges, 5 edges, 6 edges, and you can go to any number of edges that you like, from a triangle to a square to pentagon to hexagon to whatever you like, octagon, and so on and so forth. Most of these are actually can be drawn using one single command. This command will follow the same sequence as a circle, so that this polygon will be fit, either the polygon that you will draw either will be fit inside a circle or outside the circle. For example, I'm talking about these polygons in here. Notice that this one is drawn inside a circle, 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 which means that if I want to fit a polygon inside a circle from geometrical perspective, then I need the corner to touch the circle. And this is one way of doing it. So, or I can actually go and draw the polygon outside the circle, and at that instant the edge will touch the circle. So we are talking about a corner and edge. All of these polygons, which are basically the same as these ones, have been drawn using the first method, which is the polygon completely, entirely will fit inside the circle. So if I want to draw any polygon, I need to know what is the radius. This is the default method. We can modify it, but this is the default method. Does that make sense? If you have any question, please, you can always ask. You can raise your hand and you will be able to ask a question. Anybody has a question? Thank you, Abdullah, for sharing the file with the team. All right.
Hello, sir.
Hello, how are you?
Yeah, I'm fine, sir. Yeah, I mean, the chat is not. I'm not able to view the chat, sir. So, like, what should I do? I mean, to view the file.
You can open. Okay. Send your email or. Okay. What is your email? Can you just? What is your email?
Yeah.
Doctor, I think if you posted it in the community, we will be able to see it.
Send me an email, I will see. So anyway, you don't need that file, and most of my files, you don't need them. I'm just using them as an examples. You can open the file and you can start working. As a matter of fact, I'll just explain and then I'll start working on the polygons without the need to actually use the file if you don't have the file.
Okay, sir.
So,
okay, fine, sir. Thank you.
Most welcome. So we are talking about two types of polygons. Either I will fit the polygon entirely within the circle, and this one, it will be inscribed polygon. Notice inscribed means inside the circle, or circumscribed, which means that around the circle, outside. So either inside or outside. I'm talking about the polygon. So I will have the option to draw. Notice that if I use the same radius, which is 40, for example, in here, notice the size of the polygon, if it's circumscribed, would be always bigger because it is outside the circle. The circle is actually inside the polygon, and it touch the edge. This is the edge of the polygon. The circle is tangent with the edge. In here, the circle is tangent with the corner. So we have a corner and we have the edge. Now, which method I will use, it depends on what's given. If the distance that's given to me or known to me, or I will be able to measure it, or this is what I measure already, is from the center to the corner, then I will always go with the inscribed to avoid calculations and guessing. If the distance is given to me from the center to the edge, then I will go with what we call circumscribed. So the distance in here, if it's given up to the face, I will go with circumscribed. If it is given to me up to the corner, then I will go with inscribed. All right, let's go, for example, and we want to draw a polygon. Assume this is a file there is nothing in this file, and I want to go and draw a polygon. The very first step is I will go with polygon from here. Select with your mouse, and if you hover around it for a longer period of time, you will see that we are giving the two options. Notice that first of all, it will be small, then it will go into large. As long as I keep my mouse over there, it tells me what are my two options to draw a polygon directly. Of course, we will have sub options to determine, do I go with this, or even a third one. So imagine that, for example, I want to draw a polygon. I will go from here, polygon, and immediately it will tell me enter number of sides. For example, I need 4 sides. Specify center of the polygon, between brackets there will be an edge. I will go back to this in a moment. But specify center, this is my center. It says in here enter option. That's the option that I'm talking about. Are you talking about inscribed, or you are talking about circumscribed? So now, or you can go right click. I want to go inscribed, or I want to go circumscribed. Now, let me go escape now. If I am drawing a polygon and my dynamic input is on, immediately AutoCAD is talking to me on the screen. I don't need to look down. If the dynamic input, which is one of the mode settings, is on, I will be able to see what are the instructions from AutoCAD directly on the screen. So I want again 4, and then immediately it tells me specify center. If you have the coordinates, you can enter the coordinates in here. Is it clear? If you don't have, I will click, and the sub options will appear to me on the screen. This is in case I have the dynamic input on. So I can go inscribed, and notice it gives me the method for inscribed polygon, which is the distance to the corner, and this is the radius. So basically center and radius, the only difference are the number of edges that you want. Is it clear?
Yes, Doctor.
Let me go and draw a circle now. I want to draw a circle for you, and this circle has a radius of 4. Exactly. 4. I will draw a polygon. This polygon, I will have it 4 sides or edges. The center will be the center of my circle. So in order for me to have the object snap on and snap exactly to the point that I want, I will go and put object snap on. Make sure that I have actually all of these object snaps are selected. 1, 2, 3. Center is selected, so I will go now and hover around the parameter of my circle. Now the center of my polygon is the same as the center of this circle, and I want inscribed. And we said that the radius is 4. If I put the radius is 4, means the distance from the center of the polygon to the corner is 4. And it will draw for me a rectangle or a square for in this polygon. This is a square and it will fit inside the circle. Now if I go polygon, 4 sides as well, same center, but I don't want inscribed. I want circumscribed. Circumscribed means that the circle is actually inside it, and the polygon circumscribing the circle. So I will go circumscribed, and I need again the radius equal to 4. 4, enter. Notice that what is the difference between this one and this one? As you can tell, this one is way much smaller than the outer. Why? Just by changing. Am I drawing inside the circle, in this instant, inscribed, or circumscribed as this one? Are we clear? Similar to any other polygon, whether you are talking about hexagonal or you are talking about whatever. And I have in here a skating board as well. Let me just show you how can I draw. For example, I have this screw and this one are complete. This one and this one are not. How can I actually finish them? The very first thing is I will go into my polygon. How many legs? 1, 2, 3, 4, 5, and 6. So it's a hexagon, and the distance is given to me as 0.3, face to face. So if it's face to face, then I need with the circumscribed. Where is the center? The center is the same as the center of my circle. So I will go with my 6 sides, specify center as center of the circle, and circumscribed, and the radius is half of what's given to me, because this is diameter from mid to mid. This is 0.3. The radius will be equal to 0.15, and enter. And now I have the other screw head as well in here. I will go to this one and try to finish it as well. Polygon. If you don't have the file, just draw a circle and follow the steps. I will go again with 6 defaults. Specify center is the same as this circle, so hover around, make sure that the object snaps is on. Circumscribed, and the distance or the radius to the face is 0.15, because this is what's given to me. So now I finished screw head, and 1, 2, 3, 4, I am done. Remaining is this bolt in here. I want to go and finish it. What I have is the other one, which is now the diameter is given to me from corner to corner, which means that this is inscribed. It should be inside the circle, and the radius will be 0.31, because the diameter is 0.62, radius is half. of my diameter. Again, make sure that the object snap is on, and I will go and draw this circle, for example, is the center. I will go with a polygon. Again, I need 6. From this center, it will be now not circumscribed because it's given to me up to the corner. The distance is given to me to the corner, corner to corner, not face to face. So I will go inscribed, and the radius is 0.32, which is half of my 0.62, and this will be my bolt head. Is that clear?
Doctor?
Yes.
Doctor, I have a question. What if I want the polygon with a different orientation, like a little bit rotated?
Oh, yeah, sure. This is a very valid question. Thank you very much. We will talk about it when we reach the modification.
Oh, okay.
All right.
Oh, okay.
So we will talk about it when we reach modification. We will go over how can we actually create a polygon and then modify it to fit our needs and draw it the way that we want. There is another way of drawing polygon actually that we use frequently. I will go with polygon and then assume that I have 6-sided polygon. The center is in here, and I don't want to go into this. So I will go into escape. Before I go into this, I need to do one further thing. If the distance that's given to me is the edge, I will go polygon, 6 sides. Notice there is a sub option called edge. This will allow you to enter the edge length. If I don't know, for example, somebody measured only one leg, and it gives me as, let's say, for example, 0.1 or 0.2. So I will select edge, and it says specify first point. This is my first point. Notice now the center is out of the question. The second point, notice I have the rubber band effect, as you can see. And then I will go, let me look the ortho mode just for now, and enter my edge length, which is the distance from the point 0 up until where I want. For example, if it's 1, if it's 2, if it's, let's say 1, this is 1. So it will give me a distance equal to 1. This edge length in here, I can measure it approximately using a distance from here to there, which is 0.992. This is due to the accuracy. Once you use measurements in here, object snap is not working with us. That's why we are talking about approximately. Nevertheless, we will be able to measure in 100% accuracy once we reach that point. Now I'm just giving you quick access things that will help you once you are drawing at this level. The higher level that we go, we will be able to use more and more of these tools. We will be very fast, and hopefully we will be able to finish in a much faster rate. So again, let me just repeat. This is a method that I use frequently in terms of the measurements. Even when I measure, I don't go and measure center for a polygon. I measure a leg. That's how we do it. You don't go into a room and you measure from the center to the corner. What you do is measure in your room. If you are a civil engineer, you measure one direction, length, width, and you need to draw. You don't go and measure. You need to find where is the center and. You know what I mean. So what I will do is go into a polygon, 6 sides, for example, or 4 sides, or 5 sides, for example, and then I will go into the sub option edge. You can access it using the letter E as well. So we can go E in here and enter. And once it says specify first point or first end point of the edge in here, I can look the ortho, or I can give it any orientation that I want. So specify second point, for example, I want it to be 1, tap, and the angle in here, I need it to be 45. This is one way of doing, actually draw a polygon with a specific angle that you know. If you want to rotate it, that's a modification that we will talk about it later. Is it clear?
Clear, Doctor.
So we need all of this dynamic input to be on, otherwise I will not be able to do most of these things. I hope that we understand, and I hope that we will go now to the second command, which is another important one called ellipse. An ellipse basically a curve, the shape such as this one. It has two axes, major axis and a minor axis. It has a major radius and a minor radius. And the ellipse command is located in this icon in here in the drawing panel. If I go just below the polygon, I can see that I can draw polygon in different ways. Center, axis, elliptical. The most important ones is the center and the axis for 2D drawing. Center and axis. The center and axis end basically are the same, but where do you start? The center means you start in the center, the axis means you start at one end, and then you finish with the center, or the radius from the center. So let's go and draw, for example, a polygon. I have a polygon in here. This is 24 by 14, and this one is an ellipse, sorry, 24 by 14, and another ellipse in here, 15 by 8. I will use the two methods to draw 1, 2. So I want to draw this one, and I want to draw this one. And now I will go always to my ellipse command. I will select, for example, the first method, center, and I will draw the first one. It says again, specify center of the ellipse. Center of the ellipse, this is my center of the ellipse. Immediately, it will tell me what is your end point of the axis. So now from the center, how much do I need to move to the right or to the left, or up or down? So I will go in this direction from the center and give it, for example, for the big, I will go into 12. And now immediately it will tell me, okay, how about the other axis? Because you are asking for an ellipse. In this ellipse, there is always a sub option. You don't need a modification. I can actually change the rotation from here using the command R or sub option R. Again, ellipse, center. I can go up, for example, from the center in the minor axis. It will be from the center to the top of my ellipse, and that will be 7. So I'll go 7, for example, in this direction. Notice there is an extension line, a brown line. This is a tracking line, if you remember. It's tracking from the center. How much up? I will go 7. Immediately it will tell me, okay, how about the other direction? Or do you want to rotate it? Rotate, for example, and give it, for example, I want it to be 15 degrees from the horizontal, and it will finish my command based on the radius that I selected. Let me just go back and forget the rotation. Let's go into the very conventional way. I like always to draw the ellipse and then modify it using the modifiers, which we will learn inshallah today. So I'll go with center. From here, I will move from the center 12, which is the radius, the major radius. Then I will go up now to the minor radius, which is equal to 7. And this way I will draw this ellipse and this ellipse. Remember that if you want to know the properties of your ellipse, you have control 1 is on already, which will bring the properties palette. And once I select it, I will hover around the icon in here, and it tells me exactly where are the coordinates. And this is the minor radius, as you can see, equal to 7. And the major radius is as well is given to me. This is the minor and the major axis as well. Is that clear? Is it clear?
Clear, doctor, yes.
All right. If I want to use the other method now, I will use not the first one, center. I will use axis and end. Immediately it will tell me specify axis end point. In here, how much do you want to go? This is axis, end to end. How much to draw the small one? I will go 15. Immediately it will snap in the tracking to the center, and it gives me, okay, how about the other one, the other dimension from the center now, not from the axis. So this method will involve two things, one from the end, one from the center, the other dimension. So from the center, how much you need to go up? 4, and this will create for you 2 ellipses, 1, 2 ellipses, and I can actually use these two methods. It depends on what's given to me, how I am flexible. The flexibility is important. I'll go over an example in here. And I want you to try to follow me. I will take it slowly for this sink. I'll draw it. There is a sink hole in here. This is the sink looking from the top, and a sink usually looks like this. There are other shapes, but this one is an elliptical sink with a hole in the middle. And I want now to use my commands. Forget about the magenta color and the green color. I'm talking about the sink itself, the object itself, which is in the cyan color, which is this one, and the hole. These are the three things that will actually form my sink, ignoring all of the annotations around it for now. Are we clear? If not, please, you can open the mic and ask. So I will draw the sink in here. The first thing that I need to do is I will go with an ellipse. And for example, I will use the default in here is axis and end. So I will draw the big one from axis to axis. As you can see, it's 20 inches, 20 units for you. So I will go with 20, and immediately it will give me, okay, how about the other direction? And the other direction for the big is half of the 16 from the center. So the minor axis will be radius. The minor axis radius will be equal to 8 from the center. This is the big one. And now I need the small one. Now certainly to draw the small one, I cannot use axis and end because I need now to go and find exactly where is this point. So I need to be smart about it. I will go and select center. Center of this ellipse. Notice it will snap. My object snap is on. Center is selected. So hover around it, and it will tell you, okay, how much you need to go left, right, or how right, left, or up, down, up, or up, down, wherever you can go. So I want to go in this direction, for example, for the smaller ellipse of my sink, the entire axis is equal to 12. The radius is equal to 6. So I will go down 6, and then now I need to go into, notice that there is a dashed white line. It gives that, it says that I need this dimension now. Enter it. I don't need even to move in this direction. I can just keep it in here and enter that data. How much that would be in the X? It will be half of my 16, which is 8. And this is my other ellipse. So now we are talking about, we drew two ellipses, one using the axis and end, the other one is using the center and radius. Why did I use this one and that one? I can use center, both of them, no worries. But I just wanted to show you how flexible we can be and why do we need the two commands. If we agree on that, the remaining thing is the sinkhole, which is this one. And the sinkhole, I know a little bit about it. Usually my students, when I give them this exercise, they start thinking, okay, how can I draw this hole? Am I right, Ashraf, Abdullah? Am I right? So we need always to go and draw it it in a smart way. How? I will go into circle, and I will use a command that I taught you before, TK, last time, tracking. So I will go with the tracking from where? From the center of my circle. How much do I need to go up? I need to go up 4. Is that clear? So I will go again. I need to draw a circle, center, TK, enter. From the center of this circle, I will grab the center, object snap is on, move up. How much? 4. Did I reach my point? Yes, enter. And then I will give it a radius equal to 1. And this would give me 100% accuracy, and that will enable me actually to draw the ellipses of the sink as well as the sinkhole at a distance of 4 inches from the center up. I hope that most of you followed me and were able actually to do this ellipse. All right. If you have any question, please, you can always stop me. You can always ask me, and I will try to answer your question.
Sir, can you please show the last part again? The
Sure.
sinkhole.
Let me just go and repeat the entire thing for all of you. I will go with an ellipse. For example, I want to change and I want to start with center. So I will start from the center. This is, for example, the center. And I can move up, down, right, left, and give the distance. As you can see, it says specify endpoint. So how much this for the biggest one from center to the edge, the major axis 20, half of it is equal to 10. So I will go 10 horizontally. Then vertically for the large from the center up, it will be half of the 16 inches, which is equal to 8. Now I will go using the same command. Again, we know how to repeat the last command. Right click, repeat, or space bar, if you remember. So repeat from center in here. I will go to the right for the smaller one, smaller ellipse. The radius, major radius will be 8. Another point says ellipse. From here, I will go right, left, up, down. For example, right, I will go from the center 8, and up, I will go 6. And this is my 2 ellipses. Both of them have the same center, concentric ellipses. I need to draw the little hole, the sinkhole in here. I know that this one is from the center up 4 inches. The center of the circle is 4 inches from the center of the ellipses. I know the center of the ellipses. I need to go and draw the circle. I can, in another way, for example, make my life easier. Go to the line from here and look the ortho. Go up and draw a line of 4 inches. And then bring a circle. The center will be the end point, and give it a radius equal to 1. And then I'll take this line and delete this. That's one method. I prefer the TK because I don't need to repeat. It will be faster for me. So I will explain what I started with. Circle. Go with the command TK. And then it will, first tracking point will be the center of my circle. The track line will appear. I will go up from here 4 inches to reach the center. I reached the center from the center of the circle from the center of the ellipses. I confirm by enter, and now I will be able to go and enter in here the radius of my circle, and it is actually, I remember as it's 1. Enter it 1, and these are the ellipses. Sometimes, guys, it looks like, and you draw an ellipse and it looks like there are edges. Don't get fooled. The easy way is actually to go into the command menu and apply regen. It will regenerate the model for you, and it will look like an ellipse or a circle, the actual one. It depends on the scale and how much scale are you using. Some of the resolutions will not appear as an ellipse. It looks like a bunch of lines, connected lines. You don't worry about it. You just go in here again and you go RE, regenerate. If you try to zoom in or zoom out and it stopped, you can go always again with RE, regen, and enter. Now in the new CADs, this problem is being minimized, but in case it happened to you, this is what you do. Any question, guys? Any question?
No, Dr. Clear.
Perfect. The last thing that I want to talk about in this chapter is about what we call hatching, which is nothing but applying a pattern inside or outside or in between. Usually inside or in between. There is no outside because you need to have a boundary to go into hatching. Hatching is this command in here. Hatch, as you can see. And the hatch is actually very easily done. It will open for me a new tab. Notice when I click on it, immediately a hatch creation tab will actually open for me with all of these commands. Usually it's hidden from you. You don't see it. So if you go exit, it doesn't appear. AutoCAD have some of these tabs are hidden. One of these tabs, or the most widely used one, is the hatch. If you click on it, of course, you have different hatch pattern and how you select a boundary or you create a boundary and so on and so forth. What we will do is we will focus on the hatch in here, and immediately when I hit it, it will open a tab called hatch with all these panels. I need boundaries first, and then the pattern that you want to select, and if you want to apply transparency, if you want to rotate it with an angle, if you want to change the scale, all of this is going to be done in this menu. Once you are done, either you go escape, select one tab, or you go close hatch creation, and it will actually help you to reduce the amount of tabs that you have in your screen. If you keep adding all of these tabs, the screen will be full and you will not be able to see most of these. Any questions so far?
Doctor, so what does hatch exactly do?
I will explain. I'm just preparing you. I will talk about hatch. Hatching is actually applying a pattern to distinguish between different materials. From civil engineering perspective, we need, when we use, for example, to build a tunnel or a high-rise building or a dam, or we have several materials and several details that we need to show. Or for example, I will go into an oil exploration and I need to go and represent all the soil and rock layers up to 1 kilometer below the ground. How do I do this? I need to go and apply hatching. For every type of material, I will apply a hatch, and this hatch will be attached with a legend. So, and if you open the hatch in here and you go into, for example, I want to go and apply a pattern, you have different patterns, either solid, you have a gradient, or a pattern, which is what most of the time in engineering, we use this one. And I will select one of these. Notice that if I click the menu in here, let me just close it. I will go into this little rectangle with a line and click on it. It will open for me the available standard patterns that we use in mostly in engineer as civil or mechanical engineer. So you have a solid pattern. I can apply a solid pattern. I can apply angle. I can apply the American National Standards system, and that would be, there are several patterns. ANSI 31, most famous one, ANSI 32, ANSI 33, 4, 5, 6, 7, and then it will go after 38 into different materials. For example, block 816, block 816C pattern, block B88, this is brown, this is pre-stressed, you have concrete in here pattern. We have other patterns, as you can see, this is the concrete one that we talked about. This is for the roof material. We can represent sand. You can actually design your own pattern. You have, for example, clay pattern, cork pattern. We have the earth pattern, and you can select any pattern up until this one, or you can create your own, change it into a block, and then move it as a pattern. You can do that. So if you don't find yours, find yours in here. For example, you want to represent limestone and you don't find it, or dolomite and you don't find it. What you do, you go in here. These are for different patterns, and then you go into, for example, if I have hexagonal pattern, honeycomb, I have gravel, for example. So imagine that I want to go and apply gravel, which is a natural material that exists beneath every structure around the world. You need to study this, of course, this behavior of these gravels and how they're going to behave and what kind of minerals they are holding and so on and so forth. Part of the application, most of these applications comes into civil engineering. So if you go into, for example, gravel, and I want to apply a gravel pattern in here or in here, notice when I hover around, sometimes it doesn't appear, sometimes it appears. Means that the scale is not good. The scale is not good because I do not see what's going on. Where is that scale? The scale is actually located in here. And for example, I will change the scale to 15, come back in here, hover, notice, I will be able to see the gravel pattern. I can make it larger using the scale. I can make it smaller using the scale. So I will apply this one. Once I hover around the circle, click, and the pattern will be applied as one object. Notice all of this is one object. Is it clear?
Yeah, Doctor, the scale, Doctor, is based on what? And the diameter of the circle
is based on the template that you are using and the scale of your drawing. We'll talk about it in the future, but now a scale you need to try until you fix it at the beginning. To be honest with you, it's gonna take some time from you and a little bit of more tools in order to be able to understand the scale. Eventually notice that whenever we want to produce, thank you for your question and let me elaborate on this. Whenever you want to produce a plan, a construction plan, for example, for any, even if you want to design a car or whatever, your final design need to be printed. The scale depends on the size of the paper that you will use to print. Is my size, because you know the size of the paper, for example, I have A4, most famous, we use it, all of us, am I right? You have yes. A3, which is bigger, you have A2, you have A1, you have A0, which is huge. So now the scale of my drawing and whatever on my drawing need to match what size of paper I'm gonna use.
Sir?
Yes.
So can you show again how to apply the pattern?
Yeah, don't worry. I will do it. I will do it frequently, but just I want to answer the problem with the scale first.
Okay, sir.
Thank you, Ramin. So I will go and actually look into the size of the paper that I will use eventually to give, or as an engineer I will use. And based on that size of the paper, I will choose the scale. Yes. Is it clear?
use them for again.
Perfect. If we have time, I will be happy to teach you how to do this in toward the end of the course.
Sure.
Once we want to produce the layouts.
Doctor,
Yes, go ahead.
can we grate our own butter?
You can, but that will be toward once we reach blocks. We can create, yes.
Okay, thank you.
You are most welcome. You can as well borrow. Most people, they go and take it from other drawings. Is it clear?
Clear, Doctor, yes.
Perfect. So what we will do is, again, let me repeat this exercise. I had previously a circle as this one. Now I want to apply a pattern inside it. How? I will go into hash to differentiate between the materials. For example, this material is gravel and this material in the middle is sand. Why do I need this? Believe me or not, if you want to, for example, build Khalifa tower without knowing the properties of the material underneath the tower, whatever you see doesn't make any sense. Whatever you can build above, if you don't understand the behavior of the ground, will not help you a bit. So we need to go and do something called soil or site investigation. And usually depends on the size of the projects. You need to spend money, a lot of money, just to generate information about what's going on. And we have lots of technologies, geophysical technologies. We can send waves inside the ground. And there are few people who actually can use these type of techniques in which we are actually sending waves in the ground and then receiving the signal back, and based on the speed of our waves inside the ground, we will be able to figure out what type of material we are having at each depth. If we have water, for example, if we have rocks, what type of rocks is that? If we have, for example, sand, what type of sand is that? Because there are several types. Then if we have cavities, because in the United Arab Emirates, we have what we call karst formation. This karst formation, one of the biggest problems that we are facing when we go high-rise buildings. Even small buildings, if there are cavities under the ground, once we start building, the stress coming from the buildings will crush these cavities and it will cause a lot of problems for our buildings. So we have, for example, nowadays we use ground penetration radar as well. And the ground penetration radars can be mounted in an airplane, can actually move on the ground. It depends, can we do it or not in the ground? If not, then we can mount it to an airplane. Can be manned, unmanned, on a drone, whatever. But the technologies that involved in this subsurface exploration are huge. And still there is a huge room for development. So we need very smart people to go into that direction. Again, civil engineering is no longer the same thing that you can just imagine in your head, I'm going to build a two-story building. This is not civil engineering. Other applications and lots of technologies are involved. Unfortunately, we have a few people who knows all of this. We need people who can actually know and develop the tools as well and write the codes in order to be able. So the best combination is somebody who likes coding and goes into civil engineering. That's the perfect combination, where they can develop different models using coding programs, using artificial networks, using artificial intelligence of any model, and based on these codes, they will be able to actually go and develop programs, or using these tools, being able to reach what we are expecting between 2 points, based on, for example, a model coming from neural networks, which is basically part of what I'm doing right now in my research. So now I need to differentiate. Imagine we did all of this, and we need now to differentiate between two materials. Imagine that I have a gravel. This doesn't make a lot of sense, but this is my example, and inside it in here I have sand. Then I will go into my hatch, click on this little arrow, come down in here and find in my material. If I go a little bit down in here, this is my gravel, as you can see. So I will go gravel, and I hover around in here. I cannot see. In here I can see it, but it's very dense, which means that the scale is not good. What I will do is go to the scale, for example, choose 15, select in here, I'm satisfied. In here, for example, I want to make it larger. I will go into a scale equal to 20 for now, and click here. Now, I just want to show you one thing that's really important in the method of selection. So let me just repeat this exercise from scratch. I'll start with the circle and then move into this pattern just to show you how can I select. So I will go hatch. Immediately in the first panel in here, it says, do you want to select a boundary, pick a point, or select the boundary itself? So I can pick a point inside the boundary, or I can select the boundary itself. Now the boundary assumes that all the lines are connected. So for a circle, for example, if I go select a boundary, and I will use the same scale 20, and I will use a gravel in here and select this boundary, it will apply the hatch inside. It will fan from where you selected, touch this boundary, and hatch everything. Similarly, for example, if I want to select this is my boundary, I will go hatch, select a boundary in this little arrow to the far upper left corner, select a boundary. If I select this boundary, it will select fan in and do all the hatch, but this is not what I want. I want only between this one and this one. So I can select the other boundary as well, and AutoCAD will trim and escape. So I can select two boundaries. Let me repeat. This is a new modification, by the way. Even my students don't know it. This is only in this version of AutoCAD, the 2021. Am I right, Fadi Abdullah? So go hatch. I will go with gravel 20, and I want only between these two. I will select first boundary. While I am in the command, I will select the other boundary, and it will do the hatch between the two. That's one method. I'm done. I will go close. Now I have the hatch, as you can see. Let me do it in a different way. I will go hatch, but instead of selecting the boundary, I will pick a point. When I pick a point, AutoCAD will fan in and out, touch boundary in, touch boundary out, and do a hatch between the two boundaries. So if I select a point in here, notice it will hatch, it will fan in, touch the internal boundary, fan out, touch the external boundary, and hatch in between. If I go inside in here, notice it will fan in, no boundary. Fan out, it will find this square as a boundary and hatch. So I can select this point, it will hatch. And then, for example, I will hatch in here another pattern. Let's go, for example, a honeycomb pattern. And I will go and select it in here. And now, for me, these are two different materials, such that when I print and plot my plans for construction purposes, for example, or producing a design of a certain dimensions, people will understand that this is one material and this is another material. And you tell me, well, these are two materials. Yes, people will understand that easily. Now I'll tell you that if you have a very complex cross-section that consists of 200 alternating materials, then you will never know which is which. Am I right?
Yes, doctor.
And the third one in here, notice that these points are actually not a boundary. So I cannot go and say, for example, hatch, gravel, and I want to select a boundary. You select this one, and immediately you will see nothing in your AutoCAD. There is nothing. It will tell you pick internal points, for example, or undo, or settings. Change something. There is nothing. I don't see anything in here. Why? Because this is not a boundary for AutoCAD. Boundary for AutoCAD needs all of these lines to be connected as one. So in this instance, what we can do, let me just close and repeat. Hatch, I will not select a boundary, I will pick a point. A point inside. This is how important the selection for hatching is. Click, now the hatching is done. These are the most important things in actually drawing. Let me just, before I leave, let me close. I'm done with this. Of course, and if you want to go back, just double click in here. The menu will open and I can come to the scale, for example, and make it 10. Make it more dense. Do you understand me? If I want, for example, to change this pattern, I can delete it. Or I can come back in here and I want to select hound. Or I want to go and put, for example, in here concrete. I will go into the concrete. Where is the concrete? That's concrete. And then I will select it in here. The scale is a little bit large. I cannot see it very much. Let me go and make it 5. And this is the hatch for concrete material, as you can see. Are we clear? If I don't like it, I can always change it. I can change other aspects that I will talk about in a little bit later. I can associate and de-associate. Means I will connect it with the shape or not. By the way, if you want sometimes to do a trick, drawing a hatch without a boundary, you put the boundary, you put the hatch, and then after that delete it. And you will have only, it will always associate it with a circle. I'm done. I will always go escape, or I will go in the menu and click in here, close hatch. Done, done. All of these are one object for AutoCAD. That's one of the most important aspects of hatching. And all of them will be actually one object, stored as one object in AutoCAD. Rather than create thousands of these particles, you are creating only one, which means that the size of the file will be always under management. You will be able to manage it. Are we clear?
Clear, doctor, yes.
Let me close. Did I answer all of your questions? Do you have any questions still? Why do we use the hatch? How do we use it? What is the scale? These are the things that I remember. Do you have any question, ladies and gentlemen?
No, doctor, everything is clear.
Perfect. Let's go into chapter 7. Actually, not chapters. These are just go into now a little bit of more, but I will stop talking about drawing. Before I stop, let me go into just to draw a few things. For example, arc. Arc, I can draw it in many ways, actually. If you click on this little triangle in here, you can draw an arc in any way. For example, the default is 3 points, as the name indicates, 3 points, 1, 2, 3. This is an arc. For example, let me just show you. I have, let's say, for example, a line in here. Another line in here. And a third line in here. I'm going into the space bar, guys, to repeat the last command. Instead of going line, 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 my left hand is actually in the space bar, and that is actually how I create another line and another line and another line. Just a space bar, you go back, or right click, repeat line, or a space bar, it will repeat a line, and so on and so forth. So assume that I have these 3 lines and I want to draw an arc between these 3. I will go, for example, 3 points. My object snap is on 1, 2, 3. And I don't need this line, for example, delete it. I don't need this line, delete it. I don't need this line, delete it. This is an arc, which is basically a part of a circle. Once you create it and you select it, it will tell you where is the center. Is it clear? And that will bring me, actually, of course, there are other ways. It depends again on what information given to you. I have start, center, end. It will, for example, where is the start? Where is the center? Where is the end? I have another drawing arc, for example, using start, for example, center, start, and end. Center is in here. The start is in here. And then I will be able to draw the circle, the right, left. So if I go in here, I will make it smaller. And then as I move, it will be larger until it ends as a circle. Is it clear? So that's another way. It depends on what information given to you, you will be able to draw the arc. So you need to think and choose one out of these. Almost how many? 1, 2, 3, 4, and 4, 8. We are talking about 11 different methods to draw an arc based on what is given to you. Probably 3 points and start end radius are the most widely used ones. So I will just go into the 3 points. And there are other small, less used commands. For example, I can draw what we call an SP line. SP line means it will draw a fit between points, through the points or between points. This is SP line fit, and we have SP line CV, or control vertices. I can draw other stuff that I will visit when I need, because there are so many drawing things that you actually don't need. Another example, just to be fast, is array. How can SP line is very flexible. Just go back to SP line. Notice I can draw and twist lines. This is good when you want to draw, for example, fit through points, a curve between points. This is, it will be calculated and draw, or you can do it randomly. Once you're done, you go right click and enter, and this will be your SP line, which is fit through the points, as you can see. If you go into, I need to draw SP line control vertices, notice 1, 2, 3, 4, 5. I'm giving the control vertices. Right click and enter. This is the curve. Notice it is a fit between the control vertices. This one, SP line fit, passes through the points. This is the two difference between this one and that one. It depends again on what type of information. If you just want to randomly draw one, you can select any. Another drawing command we can use is what we call the ray. The ray has a start, and then it can go to the end, literally, virtually the end. And if I select these 2 points, no matter how much I'm zooming out, I'm zooming out, and we're talking about e to the power 20 now. Still, it's going on. So it's array. It has a start, it doesn't have an end. Why do we use this? We will probably touch on why do we need them, but not now. Let me close this file, and then I will go into my chapter and I will start talking about some of the modifications. Some of the modifications. One of the most important things that you need to know about AutoCAD that every object has what we call vertices, control points. It depends. For a line, for example, you have one at each end and the center, or the midpoint. For a circle, the control points will be the center and the 4 quadrants, and so on and so forth. For an ellipse, you need the center and you need the 4 quadrants as well. For a rectangle, you need the corners. So I need always to go and be able to be flexible. You commit a mistakes, you need now to draw fast and then be able to modify. So imagine that I have a piece of machinery. I'm looking at it from the top, or it can be a piece of furniture, or it can be a pool if you like. This is a casket for an engine. So what we have is I have an ellipse in the middle. I have 4 circles in here, and my drawing is the white one. What is needed is the green one in here. How can I actually make sure that this one exactly the same as that one? Let me start by the circle, and now you need to make sure that the control one, the properties palette, is actually there. So I will go with this circle, this circle, this circle, this circle. Ashraf, and can you upload this, Abdullah?
We are searching for it, Doctor. We'll upload it now.
All right, thank you. So that's the file which is in here. And then now I will go and control 1 or hover around the icon, the properties, and notice that it says for me the geometry, which is for now is the most important thing. The center varies, I don't want to change it. Center X varies, I don't want to change it. The radius varies, and all of them I need to have a radius equal to 0.25. So I will select in here, click on this and say 0.25 and enter, and AutoCAD will comply with my command. Notice that all of my circles in here have the same radius. If you don't have the file, guys, I want you to do the following. Let's go and draw a rectangle, and we know how to draw a rectangle. For example, from here, I will go right click, dimension, and I will give it, let's say, 4 by 6, and enter. And this is my rectangle. Inside this rectangle, I will draw a circle from the center in here randomly. Let's say any circle. So I will select just 2 points. Another circle in here and 2 points. A third circle in here and center and another point. I'm not entering any dimension. I'm just plotting any circle. I actually don't know any information about this. How can I make all of these having the same properties? I will select 1, 2, 3, 4, and go to the properties palettes. Hover around it, it will open a menu. As you can see, go to the radius in here. And for example, I want to unify the radius of all of these circles to be 0.2. So I will go 0.2, and notice that all of my circles now have the same radius. So AutoCAD will comply with whatever the properties or the control or the changes that I apply in the properties for the control points of the circle. So now I changed it, all of these, 1, 2, 3, 4, to a radius. How this is in civil engineering, what we read, this is R radius equal to 0.25 of the whatever units, typically 4 holes, which means that I need to look into 1, 2, 3, 4. All of these are having the same radius, which is 0.25. Is it clear? Now the ellipse, this is the ellipse. Again, this palette is command sensitive. The geometry will be different. Center, I will not worry about it, but I have now the radius in here, minor radius and major radius, if you remember. Is that clear?
Yes, Dr.
So the major radius in here is 2. The
Doctor,
minor radius is 1.25. Enter. And notice that my ellipse complied to the changes that I apply. These are the things that I changed. This is one way. Or you can actually, let me just undo. This is the ellipse and that I want to change. I can come back and select this vertices. Once I select it, notice it becomes red. And it will allow me to enter the data. There is a highlight on a number and the number is changing. So I need this axis to be half of the 2.5, which is from the radius 1.25. So I will enter in this one 1.25 and enter. And then I will go into the other vertices and then move it up or down. How much? From the center, I need to move it by to make it equal to 2. So I will enter 2 where it's highlighted and enter. Now this ellipse is identical to this one. Is it clear?
Yes, Dr. Clear.
This is one of the most important modifiers that we can apply, and it will help us to control the geometry, change the geometry, make it larger, make it smaller as we like. Let's go into another important modifier, which is called move and copy. I want all of you now to draw a polygon such as this one. Properties is equal actually to the length is 5 inches, 5 by 5. It can be a polygon or it can be a rectangle as you like. And the circle in here has a radius of 3 inches or 3 units if you are using a CAD ISO. So I will go with a rectangle, right click, dimension, 5 by 5. Was it 5 by 5 inch? How much is that? Let me just measure. Distance from here to there, that's in feet. Let me go and draw it 15 by 15. So I will go rectangle from here, right click, dimension, 15 by 15. This is my square, and then I will go with the circle, and the circle, as we said, the radius is 3 inches. So I will go circle, I will draw it in here, and the radius is 3. So now if you start from scratch, I need you to have these two. If you have these two, let me go back in here. I want to move this circle such that the center of the circle is exactly at the corner. First and foremost, to guarantee 100% accuracy, now you become experts. You need the object snaps to be on. And I need these 3 ones at the top in here to be selected. If they are not selected, such as this one, what do? You select 1, 2, 3 and leave it. Now I'm talking about the second panel in the Home tab, which is Modify. I will focus for this class and next one on how can I modify a drawing. Are you following me? So the first thing, I will go into Move. Where is Move? This is the movement. Moves, it gives you the option to hold an object and specify a distance and move it in that direction, whether using the object snaps or using a specified distance that you want. So I want to move. I will select a move. Most of the modifiers always will ask you first to select an object, i.e. if your dynamic input is on, AutoCAD tells you in the screen, select object. If not, you go to the command menu in here and it will actually go into and says select menu. By the way, if you don't have this, if it's closed in here and you don't have it, let me, do you want, yes, I want to close it. If you don't have the command line, you go Control 9. Control 9 and it will actually appear if you don't have it. It says in here, type a command. What do I need? I need to move. By the way, I can write move. Enter. So I can write it. If you like coding and you don't want to just icons, you can just go and click move and AutoCAD will tell you move what? Select an object. I select an object. Most of the modifiers will follow the same sequence of commands, by the way. You need to know how is the sequence so that always you do the same. Apply the command, select an object. Once you select the object and you are done with the selection, AutoCAD will ask you to select an object. Select an object. It will tell you. And if you know that this is the only object that you want to move, you need to confirm. How do you confirm? You go right click. Right click now is to confirm the selection. And it will be highlighted. Your cursor will look different. Now it says another thing. AutoCAD is telling you specify base point. From where do you want to? I want to move it from the center. And notice now I am holding it. I don't have a rubber band effect anymore. I am holding it with a tracking line. From where do you want? From the center. To where now? Specify second point. Or you can specify distance in direction. For example, I want to move it in this direction. Let me look the ortho mode. I want to move it in this direction, 10 units. That's also a valid option. Am I right? You can do it. Let me just go and repeat. I'll go again. Move, select object. This is the object. I'm done selecting the object. Perfect. What do I do, guys? What do I do?
Right click.
Right click. Now, from where object snap is on, I will go in here and I am holding it from the object snap that I selected from the center of the circle. To where, for example, I want to put the center exactly at the end point. So I'll select the end point. I'm zooming in just to show you. And now the circle center is exactly as the edge of or the corner of my square. Now I can go as well and copy Copy what? For example, I want to copy this. So select object. I selected the object. I'm done. Right click. Now, what do? You want to select a base point. I want to move it from the center. Notice, 1, AutoCAD assumes that you want to create more copies. For example, 2, 3. I'm done. Right click and enter. Notice that.
Again.
Sure, I will do it again and again. Don't worry. Notice that the purpose is I created an object, and instead of keep it drawing, I created copies of it. Let me just go and repeat. These are the 2 objects that I asked you to create from the beginning. We'll go into move. Move what? Move this object. Right click and from the center to here. That's 1. Now I will go copy. AutoCAD will assume that you will create multiple copies. Copy, select object. This is the object that I want to copy. Right click to confirm my selection, and now I will go from base point in here to where? For example, to here, to here, to here. If I want to in the mid, I just hover around the mid, see the triangle and select and put. I can put any copy here, here, here. I'm done. Right click and enter. And this is how can we actually create several copies of the same. If you want to be faster, it can be easily done. Copy. I don't want to move. Copy this object from the center. Put 1, 2, 3, 4. Skip. Notice that I'm now becoming faster and faster and faster. Let me show you, for example, in a practical. This is public bathroom, and I have a seat in here, bathroom seat, and I want to copy this one in each one of these toilets, in each one, such that the center of my toilet seat will be exactly in the center of my toilet. So I don't want to move. Let me copy first. Let me move, then we will copy. Move what object? This one. This one is a block. You remember some of you asked me about how can I. This is a block, series of lines that we will learn how to do them. Series of lines, and then move them and create out of them as a block. And this block can be a pattern. So this is an example. Now select an object, right click to confirm, and now I need to hold it from the mid of this toilet. What do I do with it? I will go shift right click, and I will use an object snap called mid between 2 points, which is 1, 2. So now the mid of my toilet seats exactly is the mid between this wall and this wall. Can I do it in a different way? For sure. I'll go right click, but this will take me a little bit more time. I'll draw a line from here to there, end to end. Object snap is on, and then I will go and, for example, copy this one, right click from here to the midpoint. Notice that I'm done. Good. Select this line and delete it. Let me do it in a different way now, just to show you that we can do all of these in a few seconds. How? Copy this object, right click from here, midpoint, shift right click to mid between this point and this point. And now right click, enter, copy. This one, notice that I will select now corresponding points such that I move the toilet from a distance to from a point to another point. So I'm moving this one from where I'm done selecting. I want to move it from here to there, to there. I'm moving and copying at the same time. These are what we call corresponding points. From the wall, it has the same distance. So if I move it from this wall to this wall, the toilet will be in the middle. From this wall to this wall, the toilet will be in the middle. The reference are the same, and I'm moving the same distance all the time. Is it clear? Is it clear?
Clear, Doctor.
Yes.
Do you want me to repeat? Anybody feels that I want to repeat?
Yes, sir. Can you repeat? I didn't quite
Sure.
get that.
I will go and remove all of this, start from scratch. For example, I forget how to draw a midpoint or find a midpoint. I will draw a line from here to there. Right click and enter. And then I will go and move. For example, I don't want this copy, so I will just move it. Right click from the midpoint in here to the midpoint of my line, the one that I drew. And then take this construction line and delete it. I don't need it. It's not part of my drawing. And then I will go and copy. Copy what? Copy the toilet seat. Done. Right click. From where I will use corresponding point in here. Move it to this point. So always the distance from the wall to the center is the same. To this point. Same. To this point. To this point. And to this point. Right click and enter. And these are my toilet seats. Notice that how much time you will save just by creating copies. There are even faster ways to do things. Is it clear? Specifically for many copies, and 4, 5, 6. No, this one you can do it in very fast. But if I ask you that I need 100 of these and I need you to copy, then you need to do it 100 times. While you can do it actually in one shot instead of 100. Is it clear? This is, we will talk about it probably when we reach.
Yes, sir.
Perfect. So we will talk about this again in terms of copying and creating an array, but not now. That's about the move and copy. What we did today, just to summarize and make sure that you understand everything that we talked about. We talked about art. Generally speaking, we talked about polygons, we talked about ellipses, we talked about hatching, and now we talked about move and we talked about copy. Let me try to cover now the rotate. One of you asked me about rotation, and the very famous rotation is actually our clocks and watches. And usually you will have 2 handles in here. I have only even 3, and I have in here only 1. And 1 certainly is not good enough. So what we need is to create a copy of this handle, for example, and rotate, or we want to rotate it. For example, if I want to rotate this handle to go to time 12. So we are talking about, we are in midday, not 3. So I want to fix this one. I will go to the command rotate. Rotate what? Rotate this handle. Now selection, select object selected. What do I do? As we agreed, we go right click, and then it will ask me again about base point. I want to rotate it around the center in here. Now notice I can hold it and actually enter, either pick a point. For example, using the ortho mode, I can select another point along the line of it or the tracking line and choose that point. Or I can actually put an angle. For example, I will go rotate, again select an object, done, right click, base point in here, and then I enter, for example, an angle equal to 15. If I want to go the other way, I will go minus 15 to rotate it this way. If I want to counterclockwise, I will use positive. Clockwise, I will use negative.
Doctor, can you show again?
I will show you again. Rotate, select object is in here, right click around the center. And I want it, for example, to go 15 degrees clockwise. So I will go minus 15 and enter. I can actually, in this command, rotate and copy at the same time. So for example, I want to create another handle. This other handle, I need it to be exactly to tell me the minutes. So hours and minutes using the same size of the handle. What I will do, I will look into rotate. Notice the selection. I will select using my click on my mouse, the left click, right click to confirm, and then base point, this one. Before I enter a rotation angle, there are sub references in here and copy sub options, or I can go right click. I will go now, I wanna rotate and at the same time I create a copy and rotate it. So copy, notice that I have another handle in here. And I want to create one and I will give it an angle equal to 90. So now I don't need to redraw. I don't need to copy only. I can rotate and copy at the same time. That will give me the flexibility of doing things other than just copying or other than just rotating at the same time. Let me just take you into a civil engineering application. For example, I have in here a queen size bed. This is a bed inside the room. This is a master suite. And I want to have it exactly the same way, but I need it to be flipped. I need it to be flipped. So what I will do, I will first of all go into rotate. Rotate which one? This one. Right click, confirm. Base point, I want to rotate it and out this corner, but I need this to stay. I don't need to delete it. I need one in here, one queen size bed in here in the master suite and another one in the other room. So I will go copy and copy. Let me go, for example, and select another point. I'm not interested. I will select another point just using the tracking line. And this is my copy. Now I will go and move. Move what? Move this object. Right click to confirm. Base point from here. Where do I want to put it? For example, I want to put it exactly the corner to be at this corner. And now I created 2 bedrooms instead of just draw from scratch and and move it and copy it and so on and so forth. It will take a lot of time.
So?
Yes.
So if we make a 3D model of this, like generate a 3D model, can we 3D print it?
Oh yeah.
Okay, sir.
That's the 3D printer. I have one. On my camera, if you go into my camera, I can share with you. Let me just stop that. And that's the 3D printer. I use it to generate my models. All right?
Okay, sir.
Good. So yes, AutoCAD is actually, this is one of the most modern applications that we use currently in civil engineering. and we use it to develop a new material and new geometry. And AutoCAD is excellent actually in creating 2D. After that, we move it into a 3D, and from a 3D with 100% accuracy, with the proper scale, we can print using different printers. This is a small one to create small models, just a prototype. But the applications now is we can print even 3D villas. And I don't know the future, but up until now, yes, we can print up until 2 floors.
زي النماذج اللي هي بيعملوها للمولات ولا كده بيحطوها في النص على اساس انه دي التوسيع الجديده.
Yes, so these can be also generated using the 3D printer in an easy way. But I'm talking about, I'm talking about even physical houses, actual houses with the same size as your house, as your apartment, as your villa can be 3D printed.
So the 3D printer will be bigger?
It will, yes, it is bigger. If you go into YouTube, actually, you can just go 3D printing houses, and there are already houses, and some of them are already done actually in Dubai. This is why we need people in civil engineering who knows coding, who knows drawing, who knows all of this new technologies to implement them into the new applications. And the reason why I have a 3D printer is just to develop in new approaches, as well as new geometries that can serve our purposes, and see their behavior once we take them to the lab. Ashraf shared with us a YouTube video. That's a nice video that you can watch. Thank you, Ashraf. So I will go back to my screen. I will share with you my screen as well and go back to 2D. Yes, thank you for your question. So let me just repeat. As you can see, things can start from a very simple approach and make our life a little bit more sophisticated. But everything need to be start small, and we started in here by drawing lines, and now we are moving objects. Notice how much did we learn in a few classes. So I will go rotate. I can copy and then rotate, by the way. And for example, I can copy, if you feel more comfortable, copy this one, right click from here to there. This is a copy, and then I can go and rotate. Rotate this one around this corner, look the ortho mode and rotate it. And then I can go and move it. I'm just trying to show you that I can do the same thing in different ways. Is it clear?
Yes, no.
Clear.
Let me just go and see how can I do this using only rotate. Rotate this object, right click around this corner, and I will copy. And then I will move this object, right click from here to any other point. I can remove the ortho mode and move it to this point. I can TK it from one point. I can give it a distance that I need. So I can go back, for example, move this object, right click from here. I will look the ortho mode and move it up, for example, 7 inches. And then move it again in this direction, for example, another 7 inches. And now it's properly situated in my room. So notice that move, copy, and rotate, they can talk to each other, and they can make my life way much easier, and instead of drawing things from scratch. Do you understand me?
Yes, doctor.
Perfect. I prefer not to start a new exercise as of now. Let me just summarize what we have been doing today and what did we accomplish. First of all, we talked about Polygon, and in Polygon we talked about inscribed and circumscribed. Either I know the distance to the corner and it will be inscribed polygon, or I know the distance to the edge and it will be circumscribed. Or I taught you another sub-option, which is edge, if you know the measurement of the edge, which is frequently is what you know most of the time. And then we talked about ellipses, and I talked about center, axis, and end. And the difference between the two is the center need to start from the center both, the major radius and the minor radius. When you go into axis and end, means you need to start from the end of the ellipse and then from the center. These are the two things. Then we talked about hatch and different patterns and the purpose of this and how can I change the scale. One last thing before I leave hatching, I just want to you, for example, if I have this ellipse and in here a jacuzzi and I want to hatch it, I can go hatch. I just want to show you this option, hatch. So for example, I want to go into ANSI 31. So ANSI 31 in here, the scale is not good. So let me make it, for example, 10. That's the scale. Let me make it a little bit even larger. Let me go 20. These are, I can as well in here change the angle. And I don't want it to be parallel to this. I can change the angle in here. For example, I want to make it at 75 from the horizontal. I can make it even more. Do you understand me? Notice that the line started in here. And now I can move them to, for example, 84 or whatever angle. I can enter the angle in here. Is that clear?
Yes, doctor.
And select. So this is how you rotate even the hatch, if you want to rotate the hatch. Just to show different features, for example. That's how we can actually go over the hatch. We talked about the scale. We talked about different hatch pattern. Why do we want to use them? Then I moved and talked about a few other commands that we use frequently. I will leave polyline for a later stage because we need something else. We'll talk about polyline for sure, and very important. That's why it's big, the icon, but we'll talk about it later. We talked about the arc and the different methods. I selected 2 or 3 different methods. Talked about other lesser used commands such as spline fit between the points, through the points and between the control vertices. And we talked about as well construction or array. Construction line is the same as array, but it doesn't have a start point and end point. It goes all the way right and left. If we're going to use it, I will show it to you. And we have other things that we don't need as of now. In the future, when we move into 3D, we will use them if we move to 3D. After we did this and we talked about all of these, we came into modification now. We draw, we need to modify. We talked about how can we move an object. Method of selection is very important. How you're going to select, how you're going to confirm your selection, how you're going to select the base point, and then how much you move and in which direction. We talked about copy, and we talked about how can move and copy works together at the same time. And then we talked about rotate, and how can rotate and copy move together and help us along with the move. So rotate, copy, move can work with each other in order to accomplish things that are otherwise will be very difficult and time consuming to do them. Basically, the method of selection is the same, and then based on the command, you will be going into other sub options. And this is what we talked about today in terms of modification. Next time, inshallah, when we meet, We will talk about other important modifications, including stretch, scale, mirror, trim, fillet, and chamfer. We will create arrays, rectangular and polar arrays. We will go over the method of selection a little bit deeper level, and then we will go into offset command, which creates parallel copies or concentric circles, and we'll talk about arrays, and by that time you will be able to draw anything and modify anything. All right, guys.
Doctor,
Thank
can
you.
you share some exercises?
Yes, I will share with you some exercises for sure.
Sir, we are not in the team, so can you share it in the community?
Yes, I will share